All right, what's up, everybody? So here's what what I'm gonna do here is I'm just gonna work on this FreeCAD file. What if you're not following? Oh crap! I don't know what happened there. Okay, if you're not following, if you haven't been watching all these streams, I'm basically building a trailer, and I have a huge issue with the trailer. I'm like building a bathroom that collapses, and so it's kind of hard to explain, but it in the front of it there's a box that goes up, and it's a metal box, so it's heavy. And what I need to overcome is how to lift that box. Okay, so think of two boxes, one on top of another one, like that. And hold on a second. So what's happening is I've created a couple different attempts at lifting it, and none of them are working. So what I'm going to do today is I'm going to try to make this so that this will be sort of the outline of the box, we'll say. Okay. And then this triangle is what we're going to try to create to lift the top box. So let's say this is one of the outer walls. And then this point here needs to actually rotate up to push a top box up. And so what I need to do is figure out exactly how I want to make this triangle to lift this point 29 inches. And this point needs to go down 11 inches. Now it's probably not going to be like this. It's probably going to be skewed a little bit. We need to delete that constraint, because probably what's going to have to happen, I'm guessing, is that I'm going to have a pivot point in here somewhere, right? And then this point, I think this point needs to be shorter. So the leverage here will have to be shorter than the leverage here. Now I need to figure out how much, and I'm not exactly sure how to do that in FreeCAD, but that's what I need to do. So we can start with the things that we know. So I have a book here. So I'm going to do millimeters as inches. So this length, you see how I have it here. And I might also end the stream quickly because it's Easter, and so whenever the kids wake up, I got to go upstairs to do Easter, and then I'll come back down later and do that. Let's see. Let's do some royalty-free music again. Just whatever comes up, I guess. Lo-fi music. So you don't have to listen to me just drone on. Okay, so what we have here. So on this side will be an air cylinder. So air will pull this side down. And then when that happens, this side needs to go up. And so what I need to figure out is what length from here to here will make this side go down 11 inches and will make this side go up 29 inches. I wonder if I can do like a ratio. Like, would it work if I did an 11 to 29 ratio? And then figured out, what is that? That's about 1/3, right? So if I did this length from here to here, 1/3 of the length from here to here approximately, would that calculate? I guess that's my best guess at this point. I don't know exactly what to do about this situation. All I know is the situation I have right now is not going to work, and I want it to be a lot better than it is. So let's start here. So this length here needs to be 63. because the trailer is 63 inches wide. Okay, so we're just going to do millimeters, and then when I 3D print this thing, it's going to print. I'll be able to measure the millimeters of the movement of this point, and measure the millimeters of the movement of this point from up to down, and then I'll be able to know if this is going to work or not, and then I'll just take these parameters and cut my square tube to build this sort of triangle lever thing into full scale. And the other thing too is I don't know whether I should build it like this or whether I should have it more like this. I think I'll be stronger the more out I have it, and I do have space to do this this style, and I think that will make a big difference because this what I'm doing right now doesn't have enough strength. Okay, so the height is 44. So let's constrain that to 44. Okay. So that's going to be our outside. Now the mount for the inside, there's going to be, how am I going to do this? I guess this point, if I want this thing to be straight up and down, then this point from here will be, let's do this one. Okay. That will need to be 7.5 inches. Okay. So from the wall over, that's where I have this mount welded on right now. Okay. So this goes up and down like this. Now I can move this mount, right? But basically I would cut it off and move it, which is not a huge deal, but I think that's a good distance there. I mean, we could cut it off and move it closer. I had it there because the setup I was using was totally different. And what this setup seemingly allows me to do is to actually I could actually move this closer to the wall, and the closer to the wall, the more leverage I would get, which would, mean it would be less work for the piston. Now these pistons are supposed to be able to lift 700 pounds, and my box is, I think, around 400 or 500 pounds. I think it's around 400. Okay, so I haven't weighed it to know, but basically I had 320 pounds of gas shocks on it, and it made it to the point that I could pick up like a corner of the box. And so with that amount of resistance, so I think that puts it at, it's got to be, it was hard, it was a little difficult to pick up, so it's definitely over that. It's probably around 400 pounds, I guess, based on that. Okay, so let's go 7.5 there. Now the mount that I have for this point on the top box, basically the top box, there's a little ram, a little rod that comes down here, and the point that I have for that is 19 away. Now that like moves back and forth, right? But let's just say we started at some point, because as it goes down, it's going to move like left and right. Since it's pivoting here, it's going to like rotate around like this. Okay. It's going to be in an arc. Same thing with this. It's going to go around. So we can't be right next to the wall if it has to go around. But this one, we'll say this one to start with is 19 millimeters. That's what I have the point at right now. So basically this pushes up on the box at 19. Okay, and then the other side is exactly flipped and reversed. So it's over here, but it's in, where we can't see in this 2 dimension. So, but I'm just going to build them on both sides. And if this doesn't work, then I think what I'll have to do is do this again, but inside the box more, on the other 2 sides. That's what I think. If this doesn't lift it evenly. Okay, so what we end up with here is that if this point here is our pivot point, then we want, according to that math, we want this to be a third, approximately a third of this. We could figure it out exactly. I think if we take 29 divided by 11 gives us, no, I did times. 29 divided by 11 gives us 2.63. Okay, 2.63. So what we need to do is this distance times 2.63 equals this distance. I think that's what we need to do. Okay. So compared to where this is. And so basically we know this is 7.5 from that. What is this from this? It's 44. Okay. So if we go 44 minus 7.5, we get 36.5. So that's how long this thing should be. Oh, I guess we could have just done this. Yeah, see, so there you go, 36.5. Okay, it says it right there. So if we go 36.5 divided by 2.63, we get 13.87. Okay. So this distance needs to be 13.87 from here. Okay. Over, or 13.87 plus 7.5 from here, right? Which gives us 21.37. So let's do that. 21 point, we'll just say 21.4. Well, let's just do it, whatever. Okay. So what we have now is, I think, something that will work. Now what we can decide is how tall or short to make this, because I think what will happen here is that if you pull down on this, the forces, what I'm hoping is the forces are going to go in this direction. Okay. Right now I just have a bar that goes across, and the forces are going upwards at this bar, but the strength is sidewards on this bar, right? And so that's part of the reason why I'm not getting what I need to get. But I think if I pull down on here, okay, I'm going to get some amount of deflection on this, but not that much, because it's going to be pulling down this point to this point. Okay, and especially if the pivot is here, I think this is going to be a crap ton stronger than what I have right now. So basically the only thing I need to decide is how tall to make this, and then I need to print this triangle and see if I can simulate a 29-inch raise here versus here. The other thing that I need to decide is where this goes. So basically I should probably go measure how tall my piston is, because that will matter. This length here can be changed, because this will just be a bar that goes from here to the top. It'll just be a straight, like a push rod, right? But it'll be a square tube that goes up to the top box that pushes it up right here. And this distance from here down, what will that affect though anyways? Because I mean, it's like, I guess it means that I can't make this too big, because if I make this too big, then it will run into the floor. But it doesn't look like I'm going to have that issue, you know what I mean? Because basically, well, let's look at it here, because this whole thing will need to pivot. But 11 inches here needs to turn into 29 inches here. That's what we need to do. And I think that ratio will hopefully hold true. I mean, I just came up with that right now, so I didn't research that or anything. I did try to Google this fulcrum thing, but it would just wanted to talk about loads, and not, I didn't know how much load needs to be pulled off of here. I just need like this thing to be stronger, because I did put that piston in and all it's doing is deflecting my lever. So instead of pushing the box up, my lever is just bending, and I actually bent the crap out of this square tube, which is something else, I guess. But it was a thin wall. I'm going to go buy a thick wall square tube to build this out of. But I think basically I'm going to use a 2-inch bushing right here, okay, for the pivot. That is the same bushings I used on the suspension. I have 2 extra that I'm going to just put into here, okay? And so that'll be a 5/8 inch bolt that goes through them. So that should be plenty strong for what we're doing, I'm assuming. Okay, and then here is a 3/4 inch pin that goes through the air ram. And down here it's a little bit smaller. It might be like a 9/16 inch pin on the bottom here. And then these will be whatever size I want because they aren't built yet. I think the one up here is a 3/8 inch bolt acting as a pin right now. And if we did this 19 inch inwards, which I think is what I want to do, because I'm hoping that this will offset me having only 2 lift points. Like if I did them in the corners, then I might get a rocking action out of the other corner, right? If I did it in opposite corners. But I'm hoping, since I'm doing it in the middle, it will be able to lift, sort of this corner. This corner will get some lift from here, and it will also get some lift from the one that's over here, and it will kind of counteract and balance the whole thing, even though I only have 2 lift points. If that makes any sense. The lift points are in the same places, as far as side to side, front to back, whatever. But there's only 2, and they are kitty corner and put inwards. So this is the idea. So I guess what I need to do is build this triangle now. Let's print this triangle. But what distance do we want from here to here? So this distance is decided, and where this is in this box doesn't matter in this model, right? So all I need to figure out is how big to make from here to here, and I'm not sure it really matters. As far as strength goes, I would think that the more down the better, right? So how big is this? 23. Let's just do some even numbers here. 24. Now how big is this? 29. So if I make that 30, it will work. Okay, now how big is this one? 36.5. Okay, so sorry, I didn't mean to do that. So if we do that, then that's 24 inches, that's 30 inches, and that's 36.5 inches. So if I add all that up, what am I going to get here? 90 inches divided by 12. So that's 8 feet. And I can get a 20-foot square tube for $30, a thick walled. So it's 1 inch. And I don't know exactly how thick it is, but it's thick and strong. I used it on the suspension, and I think it's going to be fine for that. If it's good for that, it should be good for this. So I can get that for that. So that'll only be $30. And then I already have the bushings. It'll just be a couple more bolts. So to basically make both of these will be around $50 or $60 more dollars, which that's doable. So there's no reason to not try this plan. The only other thing that I would need to figure out is where this goes on the bottom. So this is the bottom, right? I would need to build some supports that go up to it. Okay, so if I get a 20-foot long stick of this, maybe I could get 2 of them. Because then what I could do is build supports up. They go up to it, to the thing, and then do some triangles down like this, sideways, to make sure that this thing doesn't just topple over or whatever, right? Okay, well, I'm gonna close this. And let's get this thing padded out to a couple millimeters. Well, maybe one. I'll do 1 millimeter, I guess. Now, do I want to put holes in it where I would put the pivot? Because basically what I'm going to do is I'm going to put this on a piece of paper and I'm going to draw the arcs and I'm going to measure them. And that's going to tell me what I need. So let's do that. Let's put holes in it. Let's go back to this model here and let's constrain it somewhere. So we'll actually constrain it. Let's put this dot on here. Oh wait, what happened? Why am I in the sketcher? Am I supposed to be in the sketcher or part design? Actually, let's close that. See, because I lost all my guys. They're like hiding up here. I don't know why that happened. Yeah, see, all my things went away. You know, it's like all this stuff only happens when I'm streaming. I don't know why that is. Okay, so let's constrain this to a certain distance. Let's say 10. So that will be 10 inches up. Okay, that constrained everything. Okay, so then what we'll do is we'll put our holes in based on that, basically. Okay, so 30 millimeters, 24 millimeters. Okay, so close. And then we'll make a new sketch to do holes. Okay. And I don't know how big to make these, because basically we need to do, let's try 2 millimeters, pretend it's at 2 inches. I mean, it won't be, but so let's do from here to here in distance at 12. Okay, so it's going to be kind of in here, which this might change it a little bit, but and then from here to here, where does it needs to be about there. So if we click on that, which I'm clicked on the middle dot, and then that, and then that. Okay. All right. Let's mute that and figure out. Maybe it wasn't clicked on it. Let's try 22 millimeters and see if that gets us about where we need to be for that. So we're gonna pocket that and then reverse it. Okay, so we're off. So it needs to move back over the other way. 21.5. Okay, I think that'll be good enough for what we're gonna try to do here. Okay, so let's make 2 more, one there, and then that way I can stick something in here to hold it, and then I can stick a pen or a pencil in here on a piece of paper and just drag it up and down to simulate that thing there. Okay, so let's put that back on here. We'll get it 2 more circles. And same thing, we'll go with 2 millimeters on that. Is that doing radius or yeah, that's diameter. Okay. Let's put it about where we want it, and then okay. -10. Why is it -10? Do I have this thing flipped around? I mean, if I flip it around, I still can't see it. There. If I do something like that, then I can sort of see it. Okay, I'm going to end this and go up, but you get the idea. I'm just going to put these holes in it, and then I'm going to print it. Okay, so anyways, if you have any questions, let me know. Thanks for watching.